Good morning, students. After the exhaustive discussion of alcohols and phenols, their methods of preparation and the chemical properties, the last part of this chapter is the preparation of the ether. See, ethers are actually called as alkoxy alkane. Alkoxy is the IPAC nomenclature of the ether that we have done in 11th class. Now this time we are going to discuss the preparation of the ether. The first reaction is the Williamson synthesis. Now the first time William Williamson, professor of organic chemistry from London University, he prepared ether, both symmetrical as well as unsymmetrical ether. Symmetrical is known as simple ether when two alkyl groups are same, and when two alkyl groups are different with divalent oxygen group, then it is called as unsymmetrical ether. Symmetrical ether is simple ether, unsymmetrical ether is known as mixed ether, depending upon the nature of the alkyl group. So far as reaction is concerned, when primary alkyl halides made to react with sodium alkoxide, to form symmetrical as well as unsymmetrical ether. If I take CH3, CH2Br plus NaO, CH2 and CH3 in presence of dry ether. So see, it is the 1 degree halide and it is the sodium ethoxide because of 2 carbon chain, and then this is the Na and Br is lost here, it is minus NaBr, then it forms CH3, CH2O, CH2 and CH3. Tell me anybody the common name. How many alkyl groups? There are 2 alkyl, both are similar, so it is symmetrical or simple ether. Diethyl ether, so it is known as diethyl ether. In IPAC system of nomenclature, oxygen moves to the shorter carbon chain. In this case, both sides you are getting the equal number of carbons, so eth plus oxy. What is that? It is the ethoxy ethane. It is the IPAC name. So if I take CH3, CH2Br plus NaO, sodium methoxide in presence of dry ether. Tell me, here it is the methoxide, so Na and Br is lost here once again, but this time you are getting the unsymmetrical ether because it is the ethyl another is the methyl. Take it alphabetics in common system of nomenclature. So it is known as ethyl, other is what is that? Methyl ether, or in IPAC system, oxygen moves to the shorter carbon, meth plus oxy. What is that? Methoxy ethane, right? So far as secondary and tertiary alcohol is concerned, Williamson has limitations for secondary and tertiary alcohol because in 2 degree and 3 degree alcohol, first is the steric hindrance and they prefer alpha beta elimination, and elimination reaction takes place and alkenes are formed as a major product. But for the major ether, we need primary alkyl halide. They follow nucleophilic substitution reaction. So far as aromatic ether is concerned, in your syllabus that is the anisole. So for other examples, so far as Williamson method is concerned, so if you take 2 degree halide CHNX as well as 3 degree halide, proper ethers are not obtained due to, what is that? Due to steric hindrance as well as alpha beta elimination reaction. Now so far as aromatic ether is concerned, it is ONA, sodium methoxide plus methyl chloride. So this Na and this Cl. NaCl is lost here. It is known as sodium phenoxide or sodium salt of phenol. You remember in Kolb reaction we have used this sodium phenoxide. In that where a salicylic acid is obtained. Here it is called as methyl phenyl ether, meth plus oxy, you can say methoxy benzene, or you can say commercial name is very important, it is the anisole. So that anisole is the methyl phenyl ether or methoxybenzene or anisole. All the common names and IPAC names are equal or identical, because whenever benzene gets monosubstitution, then common name and IPAC name will remain same. I take the other example here, ONA, sodium phenoxide, plus Br and CS2 and CS3. It forms Na and Br is lost here. Now this time O, CS2 and CS3. What is the nomenclature? Ethoxybenzene, ethyl phenyl ether, as well as the another marketing name, medicinal name is called, what is that? Phenitol. So it is the anisole and it is the phenitol. Now the second method of preparation of ether is dehydration of alcohol. One thing is very important to mention here, it is pertinent to mention that in case of the dehydration of the alcohol, we take similar type of the alcohol. So only symmetrical ethers are obtained. See, if I take CS3, CH2OH plus OH, CS2 and what is that? CS3 in presence of concentrated sulfuric acid at 413 Kelvin. At 443 Kelvin, alkenes are formed, but at 413 Kelvin, ethers are formed. So temperature is here playing a significant role. This OH or this H, what is lost here? It is assent to bimolecular reaction. So here CS3, CH2, O, CH2 and what is that? CS3. Ether by nature is basic in nature because of the presence of the lone pair of the electron. So it is called as diethyl ether. You take two molecules of the methyl alcohol, so you can take dimethyl ether. What's the mechanism? Very much given in your NCERT book. First step we take it, that is the protonated alcohol, CS3CH2OH. You take one molecule and this H2SO4 here, one H is here taken, so lone pair of electron is donated to the hydronium ion. It becomes CS3, that is the CH2, CS3CH2O, and this H is there. Now write CH2, and it is the positive charge, and this is the lone pair of the electron. Why develop the positive charge? Oxygen develop the positive charge because of oxygen has donated one lone pair of electron to hydrogen, and hydrogen will come back to the oxygen, which is known as ethyl oxonium ion. Ethyl oxonium ion. Next step is you take the another molecules of the alcohol. See step 2, CS3, CH2 and OH plus CH3, CH2, OH2, positive charge, and this is the lone pair of the electron. Now this carbon will give the electron to the oxygen, and carbon acquire positive charge. Here it is the lone pair is donated to the carbon, and then water is lost here. Water is lost. This is the minus H2O. Then it forms CH3, CH2O, and H. It is the lone pair and positive charge CS2 and CS3. It is diethyl oxonium ion. It is diethyl oxonium ion. Now last is that deprotonation. Right. First was the protonation of the alcohol. Second was the formation of the carbocation. Here it is the positive charge, and third is the deprotonation. Take this CS3, CH2O and H, lone pair and positive charge, CH2 and CS3, and finally this will, you see, donate the electron, and minus H positive, then it is CS3, CH2, lone pair is here, CH2 and CH3. Actually, what is obtained? Diethyl ether is obtained here. So the way we have prepared, only two methods are there in your syllabus. That is one is the dehydration of the alcohol and other is the Williamson synthesis.